This is problem 9 in the Manipulating Vectors with Trigonometry worksheet. We have a torque problem here. We have a hinged beam 30 degrees above the horizontal being supported by a rope. It makes an angle of 50 degrees with the wall. What we need to get when we do torques is the component of the tension that's perpendicular to the beam, because that's the component that rotates it. And the component that's along the beam doesn't rotate it at all. If you go over to this beam and you push straight in towards the hinge, it's not going to rotate. If you want to get this beam to rotate about the hinge, you have to push perpendicular to the beam. So we want the component of the tension that's perpendicular to the beam and the component of the tension that's along the beam. A good start would be to draw the vector T. There's the tension. And we want the component along the beam and perpendicular to the beam. It's important to know where these are. There's perpendicular to the beam. It makes a right angle with the beam. This part of the tension is rotating it. This part of the tension is not rotating it. So to get the components, we need this angle, the angle between the rope and the beam, which we'll call theta. If we get this angle, the sine of that angle times the tension is this component, and the cosine of the angle times the tension is that component. So it's a great investment in your ability to solve problems is to try to figure out that angle. There's some geometry there. What angle is that? Before going any further. So sometimes it's helpful to add more lines to the figure. There's a good line. This angle's 50. That's a right angle. That's a horizontal line, so this angle has to be 40. This angle's 30, so this angle's 60, because that's a right angle. That's a right angle. If that's 60, that's got to be 30. So now the total angle is 70. So we have the angle between the tension and the beam. Now we can get the components. The perpendicular component is 800 newtons, the tension in the rope, times sine 70 degrees. 752, that's that force. Parallel to the beam, doesn't produce a torque on it, is 274 newtons. And that's how you get the components perpendicular and parallel for torques.